In this video, I will discuss Newton's third law, and I will also try to make it clear the part where students are having difficulties with Newton's third law. Let's say that we have let's say that this is a book on a brick. So this is a brick, and the brick is on the ground. The brick is on the surface of the earth. So this is the earth. Okay. Now, even with Newton's third law, I find the system schema to be very, very helpful. So I will start with that. I have the book, I have the brick, and I have the earth. This is the earth. Okay. So we have the contact interaction between the brick and the earth. There is a contact interaction between the book and the brick. There is a gravitational interaction between the earth and the brick. And there is a gravitational interaction between the book and the earth. Okay. Now, I will do the force diagram for both the book and the brick. So for the case where the system, okay, so now I will say, okay, so the system is the book. This is the force diagram. For the book, I have two interactions, so I have two forces. One is the gravitational force from the earth on the book. And then I have the contact force from the brick on the book that points up. So this is the contact force from the brick on the book. Okay. Now let's separate this one from the following force diagram. Okay. Now let's say that we choose as the system to be the brick, and we will do the force diagram for the brick. So now we need to draw the forces acting on the brick. So we have the gravitational force from the earth on the brick that points straight down. This is the gravitational force from the earth on the brick. Now we have the contact force from the earth on the brick, and because the earth is pushing on the brick up, this force will point up. So this is the contact force from the earth on the brick. Now we also have another force. We have a contact force from the book on the brick, and because the book is pushing on the brick downwards, this force will point down. Now if you have a force diagram, one approach to do it, to draw that second arrow, would be right here, parallel. It has to point straight down. So and then I would write the force. This is the contact force from the book on the brick, and this is the force diagram of the brick, and we are here. Okay. Now Newton's third law is telling us that the magnitude, and we're only talking about the magnitude of the two contact forces, from one force from A to B, is equal to the magnitude of the contact force from B to A. Now this is telling us that the magnitudes of the two forces are the same. Now one thing that is often confused by students is the fact that the two forces are acting on two different objects. Here this force is acting on B, here this force is acting on A. What does that mean? If if you want to find these two forces on a single force diagram, then you're in the wrong direction. Because this force is acting on B and this force is acting on A, you will find one force on one force diagram, and the other force you will find it on another force diagram. So to find an example of a force pair for Newton's third law, I need to see, okay, which contact force do I have here? I have the contact force from the brick on the book. So then if I'm talking about the magnitude of the force that the brick exerts on the book, then this, according to this equation, this should be the magnitude of the force that now the book exerts on the brick. The book exerts on the brick. Now, this force is this one, the contact force from the brick on the book. This force is the contact force the book exerts on the brick. So this one is this force right here. And it is important to again remember that whenever you want to use Newton's third law, you will always find the two forces on different force diagrams. You will never find the two forces to be part of the same force diagram.